Hello, today we're going to be looking at vertex form. Let's go ahead and write that out, vertex form of quadratic functions. And we've seen vertex form before early this year when we talked about transformations. So the first way that we learned how to deal with quadratic functions were functions that were written in the form f of x equals x plus 1 squared minus 3. And we learned that those numbers, that plus 1 and that minus 3, are responsible for transformations on our graph. That plus 1, if you recall, shifts things to the left by 1 unit, and that minus 3 shifts things how? Right, so that minus 3 shifts things down 3 units. And we learned from that that our parent function, which would normally start on the origin, start at 0, 0, our new function is now going to move left 1 unit and down 3 units, and it's going to start down there. And that point right there is called our vertex. So by looking at transformations moving left and right inside the parentheses and transformations up and down outside of the parentheses, we can actually identify where the vertex of our parabola is. So we're going to look today at a couple of examples of quadratic functions that are not written in vertex form, and we are going to figure out how to convert them to vertex form so that we can find the vertex of our function. So let's take a look here. We're going to look at a question that says f of x equals x squared plus 4x plus 6. Okay, and the way that we actually convert this into vertex form is very similar to doing completing the square. In fact, we're going to follow a lot of the same steps as we did for completing the square. So I'm going to write this as y equals for a little while because y is easier to deal with than f of x. And we're going to write x squared plus 4x plus 6. And now we're going to start completing the square. So if you recall, the first step of completing the square is to clear away the c term. So I'm going to subtract 6 on both sides here. And I'm going to get y minus 6 plus blank equals x to the second power plus 4x plus blank. Okay. Next, we're going to fill in the blank, and we fill in that blank with half of that middle term squared. The middle term here was 4, so we're going to put a 2 squared onto both sides. On this side, just like completing the square, we're going to get x plus 2 squared equals y, and we've got minus 6 plus 4, 2 to the second power is 4, and minus 6 plus 4 is minus 2. And now, this is a step that previously we would have kind of done like our root, and we would have solved for the roots. But we're not trying to solve for the roots in this question. We're trying to rewrite our equation. So we're going to just go ahead and add the 2 back over right now, and we end up with y equals x plus 2 squared plus 2. And that looks a lot like what we saw on the first page, on our first page, right here, when we're written now in that form that tells us about transformations. So by looking at where we just landed here, when we look at this question and we see y equals x plus 2 squared plus 2, we can now figure out what the transformations to this function are. The plus 2 inside the parentheses, that plus 2 in there is going to be responsible for left by 2. And the plus 2 outside of the parentheses is going to be responsible for up by 2. Well, what does that mean? It means if I sketch my graph, instead of starting at the origin, it's now going to start 2 units to the left and 2 units higher up. And my graph is going to look something like that. So all we're going to be doing here is we're going to be completing the square, and we're going to use it to rewrite our formula in vertex form. So here's an example that I want you to try. I want you to try y equals x squared plus 8x plus 2. Okay, we're going to try that guy out. And let's see what you come up with. Cool. So what you should have done here is we should have cleared that c term with subtraction. We're going to get y minus 2 plus blank equals x squared plus 8x plus blank. We'll fill in that blank with our 4 squared because all we're doing is completing our square here. And we're going to end up with x plus 4 squared equals y. We have negative 2 plus 16, which is plus 14. If I want to get y all by itself, I'm going to subtract 14 on both sides. And my final vertex form is y equals x plus 4 squared minus 14. Okay, so what two transformations are happening in this particular parabola? What two transformations do you see? Give it a try. Cool, so that plus 4 should be moving things to the left by 4 units. And that minus 14 is responsible for moving my vertex down 14 units. All right. Let's do one together where that b term, that middle term, is actually negative, because I know that that's something that gives some of you a little bit of trouble when we're doing completing the square. So let's do an example of y equals x squared minus 6x plus 2. All right, so in this question, again, we're going to clear away that 2. Get rid of it on both sides. We get y minus 2 plus blank equals x squared minus 6 plus blank. And the part that really seems to confuse some of you guys is with this plus and how we're doing half of that middle number. Well, half of negative 6 is negative 3 squared. And I'm going to put it in parentheses because I want to remind myself that what we're talking about here is negative 3 times negative 3. We'll put that on both sides. On the right, I'm going to get my x, and I'm going to get, whoop, see, look, I almost made a mistake there. Let's back up, because it's not plus, it's x minus 3 squared equals, and we have negative 2 plus 9. Well, that's y plus 7. We want to get that y all by itself. We're going to subtract 7 on both sides, and y equals x minus 3 squared minus 7. If we want to talk about the transformations here, that minus 3 is going to move us to the right by 3 units. And that minus 7 is going to move us down by 7 units. All right. And the last question here, the last thing, I want you to try this last question. On the last question, we have y equals x to the second power minus 4x plus 1. Go ahead and try to convert that into vertex form. Cool, so I'm sure some of you have gotten a hang of this by now, so we're just going to take that 1 away. We'll clear the c. We got y minus 1 plus blank equals x to the second power minus 4x plus blank. The middle number here, our b term, is negative 4, and half of negative 4 is negative 2, and we're going to square it on both sides. Negative 2 squared on both sides. On the left here, I'm going to get y, and we have minus 1 plus 4. Remember, negative 2 times negative 2 is positive 4. So this is going to be a y plus 3 equals, bring down the x, bring down the minus 2 squared, and get y by itself now. So we take that 3 away, and we get y equals x minus 2 squared minus 3. All right, so hopefully you were able to convert that correctly in vertex form. Now that we have it in vertex form, What are my two transformations? Go ahead and select the two transformations that are happening here. What is that minus 2 in the parentheses responsible for, and what is the minus 3 outside of the parentheses responsible for? All right, so that minus 2 in the parentheses is responsible for a right by 2, and the minus 3 outside is responsible for a down by 3. All right, so hopefully you got some good notes on vertex form. If you need to rewatch the video to look at some examples again, feel free to do so. Um, and we will talk a lot more about vertex form and a lot more about graphing quadratics when we get back next week. All right, I hope you guys have a great weekend, and I'll see you soon. Bye.